All right, what is up, guys? Today we're going to be looking at questions 11 through 15 of the 2023 Purple Comet Math Competition. Here's question 11. Find the positive integer n, positive even integer n, for which the following equality holds true. So the right-hand side is a simple sum of squares, which has a well-known closed formula. The right-hand side also has a well-known closed formula, and since when n is even, 3 times n minus 1 is odd. Basically, it's the first sum of how many ever terms there are here, odd numbers, which has a well-known closed formula. So let's find how many odd numbers there are here. So the generating term will be negative 1 plus 2k, and we want to equate that to 3 times n minus 1. So k is 3n minus 2 over 2. Okay, so this is how many terms there are, odd terms there are. So now let's just express this in terms of closed formulas. So sum of the first n squares is this is equal to 4, and then this would be 3n minus 2 over 2 squared. So therefore we have n plus 1, 2n plus 1 is equal to, let's see, 4. And so 6, 3n minus 2 squared, squares cancel away. So now we just have to solve this. Okay, so we have n squared plus n, 2n plus 1 is equal to, if we do this, it becomes 954n squared. And let's see, 54n squared minus 72n plus 24. So let's simplify a little bit further. So we have 2n cubed, n squared, that's 3n squared plus n is 54n squared minus 72n plus 24. So we have 2n cubed minus 51n squared plus 73n minus 24 is equal to 0. Okay, now by the rational root theorem, let's just check some numbers. If we plug in 1, we see that it actually works. So we can factor this as n minus 1, and then 2n squared minus 49n plus 24. So n equals 1 will obviously be an extraneous solution, since it's an odd number, and it just doesn't make sense. And then so we have to factor this now. So 2n squared minus 48n minus n plus 24 is 0. So 2n n minus 24 minus 1n minus 24 is 0. So n equals 24 1/2. 1/2 is obviously going to be extraneous as well. So 24 is the only solution. So we have found the even integer. All right, problem 12. The positive real numbers a, b, and c have the property that the sum of these numbers is 2023, and we want to find the product. So a plus b over c plus b plus c over a plus c plus a over b is 2023. Let's write that in terms of a common denominator. So that'd be a plus b, bc, b plus c. Common denominator is abc, and then this would be ac, a plus c. Over ABC is equal to 2023. I'll put that to the other side, so 2023 ABC. Okay, so now I kind of want to get ABC terms. So what I'll do is I'll let S be the whole sum. So I'll let S equal A plus B plus C. That way I'll get ABC terms and maybe some cancellation will occur. So if I rewrite that in terms of this, I have AB, S minus B plus BC, S minus A plus AC, S minus B equals 2023 ABC. All right, so now I can factor out an S. I'll get S times AB plus BC plus AC, and I'll have a negative 3 ABC. So S, which is A plus B plus C, times AB plus AC plus BC is equal to, we have that minus 3 ABC. Let's bring that to the other side, so 2026 ABC. All right, so now let's go to what we want to find. So if we call this 1, we want to find the product of the three numbers, which is a plus b, b plus c, a plus c over a, b, c. So if you're astute and you know like your like factorizations, you know immediately what this is and you immediately know the answer. But let's try to find the factorization of a plus b times b plus c times a plus c. So again, recall S is A plus B plus C. So we can write this thing as S minus A, S minus B. Well, not in that order, but I'll make it that order. So S minus C, S minus A, S minus B. So let's see what this is. This is S cubed minus A plus B plus C S squared. And then if we choose only one S, we get AB plus BC plus ACS, and then minus ABC. Let's factor the S. S squared minus A plus B plus CS plus AB plus BC plus AC minus ABC. Now ABC is S, so these two will go away. So I'm left with this factorization is equal to, this is basically equal to A plus B plus C, which is S, times AB plus BC plus AC minus ABC. Okay. Minus ABC over ABC. Now this is very neat. We know that this red box over here is precisely what this is, which is 2026 ABC. So we have 2026 ABC minus ABC over ABC. So our answer is 2025. All right, next we have a geometry question. So triangles ABC has side lengths AB's, although ABC has side lengths 10, 10, and 12. The center of square DEFG is at the centroid of ABC. So since it's isosceles, basically the altitude will be the same thing as the median, and the centroid will be 2/3 from the vertex A. So the centroid, the center of square DEFG is at the centroid of A, B, and C, and DE lie on side BC of the triangle. So okay, so D, E are somewhere here, and then maybe like the centroid is here, like this. Okay, the perimeter of the region of both points inside the triangle and inside the square can be written as some form, and we want to find the sum of the numerator and denominator. Okay, so what points do we need? We kind of want to find this length and find this length, and of course it'll be equal because of the symmetry. We want to find this length. We want to find this length, and then what else do we want to find? We want to find this length, and we want to find this length. So we kind of want to find this pentagon's kind of perimeter. Okay, so there's some easy lengths we can find, like the side length of the square. We know that this is the center, right? And we know that this is, since it's a centroid, kind of like half the square side length will be 1/3 of the altitude length. So the square side length will be 2/3 the altitude length. So if we calculate the altitude length, this is 10, 10, 12. Since it's an isosceles, it's bisected, so this is 8. Altitude is 8. So therefore, from this base to the center, it'll be 8 times 1/3, which is 8/3, and then 2 times, since that's just the center of the square. So this is 16/3. Okay, so we found one part. We can find another part very easily. We can find kind of, if I call this x, we can find x easily. So x, yeah, we can find x easily because now we know the side length of the square. So x is going to be nothing but the height, which was 8, minus side length of the square, will this part over here, minus 16/3, which is 8/3. So if this is 8/3, now we can find this, which I'll call x. So we can set up the similarity. 8/3 over x is equal to 8/12. So using the fact that this triangle is similar to this triangle, we've come up with that proportion. Okay, so if we solve, we get 8/3x is equal to 8/12, so 3x is equal to 12, x is equal to 4. Okay, so we found 4, we found 16/3. So now we just need to find 2 more lengths and we're done. Let's put our focus on this length over here. So how can we do that? Well, first we can find EC. EC is actually fairly easy to compute. BC is 12 minus the side length, and since EC is equal to BD since it's an isosceles triangle. We divide that by 2. This gives us 3620 over 610 over 3. So 10 over 3. Okay. Okay, now the height is this is pretty easy to find. I'll just label it like this directly. So this thing over 10 over 3 is equal to the height, which is 8, over this, which is half the base, so 6. So if we solve, we get this is equal to 8 over 6 times, wait, what? All right. 10 over 3, 8 over 6 times 10 over 3, 80 over 18, 40 over 9. Okay, so that's 40 over 9. Okay, so we found this, and consequently we found that. All that's remaining is to find, I think I'll use a new color. I'll use like black now. All we need to do is find that. So what we can do is we can make use of similar triangles again. We can make use of this triangle and this triangle. So if we set up, what's the most, yeah, it is, okay, it works. So as we said, this is 40 over 9. So this length would be the side length of the square 16 over 3 minus 40 over 9, which is 48, 8 over 9. So that's 8 over 9. Kind of this thing is 8 over 9. Okay, so now we can set up similarly again. So if I call this part y, I have 10 over 3 over y. 10 over 3 over y is equal to 40 over 9 over 8 over 9. So 10 over 3 over y is equal to 5. So y is 2/3. So since y is 2/3, we can now apply Pythagorean theorem. So that hypotenuse will be 8 over 9 squared plus 2/3 squared. So that's the square root of 64 over 81 plus 4 over 9. This is 100 over 81, which is 10 over 9. All right, so we've actually found all our side lengths we need now. It's 2 times 10 over 9. So this thing over here times 2, and then this thing over here, which we found was 40 over 9. So we've now accounted for all this, and then now just these parts over here. So that was 4 and 16 over 3. 4 over here and 16 over 3. Okay. So let's add this up. We get 2, which is 100 over 9, plus 36 over 9, plus 48 over 9, which is 184 by 9. So our answer, we wanted to find the sum of the numerator and denominator, so it's 193. Okay, problem 14. So I'll revert back to purple now. So A0 is this, and AK is defined recursively as AK plus 1 is equal to root AK plus 2 to the k. And then there are positive integers m and n such that this is m plus root n, find n plus n. Okay, so A0 is 2022 times 2024. Let's experiment with the sequence. A1. So A1 would be root A0 plus 2 to the 0. So root A0 plus 1. Now, A0 is also 2023 squared minus 1 by a difference of squares. So it'll actually just be the square root of 2023 squared, which is 2023. A2 would then be root 2023 plus 2, which is root 2025, which is 45. A3 is then root A2 plus 2 to the 2, which is root 49, which is 7. All right. So we have a lot of integers, which is good. Now A4 is root A3 plus 8, which is root 15. And then A5 is root A4 plus 2 to the 4, which is root of root 15 plus 16. Okay, so now we want to kind of compute this. That isn't too bad. So 40, what's A4? 15 squared. I mean, square root of 15 squared, which is 15, plus 90, and then A15 squared. A15 squared would be 16 plus root 15. All right, so we want to simplify that completely. Okay, so now this isn't too bad. Let's just do some computation. 40 times 15 is 600, plus 90 times 16. That'd be 600 plus 1440, which is 2040. and then 90 root 15. And then we're given that this is of the form m plus root n. We want to find what m and n are. So what I'll do is I'll equate this to root a plus root b. That's more general and more simpler. And then what I'll do is I'll square both sides. So 2040 plus 90 root 15 would be a plus b plus 2 root ab. I'll bring that 2 into the radical, so it becomes root 4ab. So now we have a plus b is 2040. And now what would ab be? So we have root 4ab is root, I'll bring everything under root. So root 90 squared times 15, which is 8100 times 15. So AB would then be 8100 times 15 over 4. And now this is divisible by 4, and it goes in 25 times. So 25 times 15. And now the solution is very trivial. We can take A is equal to 20. Without loss of generality, we can take A 2015 and B 15. 2025 and B 15. Because this will obviously multiply to that, since those are the two terms, and then it adds to 2040. So answer is root 2025 plus root 15. Root 2025 is nothing but 45, so 45 plus root 15. So this is the m plus root n, so m plus n is 60. All right, and finally, we have a very nice probability question. So Jalen holds 2 coins and Haley holds 3 coins. They performed 4 exchanges. On each exchange, each of Jalen and Haley randomly select one of the coins that they currently hold, and they exchange those coins. And what is the probability that after these 4 exchanges, they end up with the same coins as they started with? Okay, so Jalen and Haley. So Jalen, let's call her coins J1 and J2. Haley, let's call her coins H1, H2, and H3. So what you may notice is that there's actually states in this game. And this actually motivates kind of like a recursive approach. You see, Jalen can either have all her coins with her, which is J1, J2. She can have one of her coins with her, so either J1 or J2, with the other coin being Haley's. Or she can have none of her coins, where like all her coins are Haley's coins. So now let's motivate this with like a states approach. So kind of like a recursive approach to this. So there's the state 1, right? J1, J2, H1, H2, H3. So this is when Jalen has all her coins. Now for the second one, let's just interchange one of them. So maybe H2, J2, H1, J1, H3. So that can happen when there's a second state when Jalen has one of Haley's coin and one of her own coins. And then finally, there's also the state where both of them are Haley's. Ordering of the coins don't even matter. So like this. So let's see, let's call these outcome after n turns. And let's call these Pn, Qn, and Rn. So Pn is the probability that after n terms we have this kind of configuration where she has both of her J1 and J2. Qn is after n terms the probability that she has one Hi and another J, kind of like J. And then Rn is when both of her coins is actually Haley's. So now let's set up like some recursive equations. So if I were to ask you, how would we compute the probability after n plus 1 terms? Well, if we're already at the state Pn, we're interchanging one J and one H. So that won't result in another state of P, we'll go to Q. So we can go from Pn to Pn plus 1. Similarly for Qn, we can, however. We just have to choose the J. I mean, we'd have to choose the H that Jalen has, and we'd have to choose the J. We'd have to choose the H that Jalen has, and we'd have to choose the J that Haley has. So there's a 1/6 chance of doing that. So 1/6 from Qn And then from Rn, we cannot possibly go, right? Because we're choosing 1h. We're choosing 1h, therefore, like, at best, Jalen will have 1h. And Pn is when she has no h's. So this is it for Pn plus 1. Now let's move a little bit quicker. Qn plus 1, since you may get the general gist of it. So from Pn, it's guaranteed, right? No matter what we choose, we'll always get to the state where we have 1h and 1j for Jalen. Plus, how about for Qn? Let me erase h2 and j1, okay. h2, j1. So what's the probability that they just, it like goes again? So if Jalen selects the H coin, that basically means that Haley must also select an H coin for it to go back to a Q state. So that happens with probability 1/2 times 2/3, which is 1/3. Now, okay, but then there's also the case when Jalen chooses her J coin, and then Haley chooses a J coin as well. That happens with probability 1/2 times 1/3. So we have 1/3 plus 1/6, which is 1/2 Qn. And then finally from Rn, how can we go from Rn? So Jalen has to choose an H coin, and then basically we need Haley to choose a J coin, because then we get to the R state. So 2/3 Rn. All right, now finally we need Rn plus 1. Rn plus 1, we cannot obviously go from Q to go to R. So she needs to select a J2 coin. And then Haley needs to select one of the H coins. So this happens with probably 2/3. So 1/3 Qn. And then also from Rn, so basically Jalen has to select an H coin, but then Haley has to select an H coin, because then when they switch, now Jalen has 2 H coins. So that happens with probably 1/3. So we've set up recurrence equations, and now let's note some initial conditions. P0 after 0 turns, obviously they're going to have that exact same configuration. They haven't done anything, so that's 1. Similarly, Q0, they haven't done any moves, so Jalen still has her 2 own coins, so this is going to be 0, and R0 is going to be 0. So now all we have to do is use this information. So let me copy what we found. 16Qn. So this may seem like a complication, but like the more you get used to it, the easier it actually becomes. Plus 1/2 Qn. And it's actually doing essentially the exact same thing as kind of like a casework approach, except we're being much more organized with our thinking. Rn plus 1 is 1/3 Qn plus 1/3 Rn. Okay. And then I'll maybe note that P0 is 1, Q0 is 0, and R0 is equal to 0. And then now we need to make a table. Like this. So we need only go up to 4 because we're interested in after 4 tries. We're interested in P4, right? What's the probability that she has her 2 J's after 4? So we're interested in P4. So that's what we want to calculate. So P when n is 0, of course this is 1, 0, 0. So when n is 1, okay, so when n is 1, P1 will be 1/6 of Q0, which is 0. Q1 would be P0, which is 1. And then Q0, 1/2 Q0 plus 2/3 R0, which goes to 0. So this is going to be 1. That makes sense intuitively. And then Rn will be 1/3 of Q0, which is 0. Okay, for n equals 2, that's 1/6 of Q1, which is 1/6. And then Q2 would be P1. What's P1? P1 is 0 plus 1/2 of Q1, which is 1/2, plus 2/3 of R1, which is 0. So this is 1/2. And then R2 would be 1/3 of Q1, which is 1/3, plus 1/3 of R1, which is 0. Okay, so like this. Now for 3, P3 is 1/6 of Q2, which is 1/12. How about Q3? Q3 is P2. P2 is 1/6 plus 1/2 of Q2, 1/4 plus 2/3 of R2, which is 2/9. So adding this gives us what? So common denominator 36, 6 plus 9 plus 8 over 36. So that's 23 over 36. Alrighty, and then Rn. Oh, actually, we need not even calculate Rn because I'm only interested in P4, and P is directly influenced by Qn. So we need not even calculate. So P4 would be 1/6 of Q3, which is 23 over 216. All right, and then probably asked us for the sum. Yeah, find m plus n. So if we do m plus n, we get 239. All right, hope you guys enjoyed that video. I'm planning to do more uploads. Stay tuned for the next video. Please subscribe and like.